in this clip I'm going to teach you how to differentiate functions where x has a negative power. Okay, so negative powers. Right, we just have to be careful really and think about how we deal with negative powers. Let's take a simple example to start off with. F of x equals 8x to the power of minus 5. Okay, so x is being raised to the power of minus 5 and then you multiply by 8. Right, let's differentiate this. Let's find its derivative function. Okay, so if you take that power and do the same thing, multiply the number in front, so 8 times minus 5 is minus 40. Okay, right, but here's where it gets a bit, you have to think a little bit. And you do the same thing, you take 1 off the power, right? So here the power is minus 5. Okay, if I subtract 1 from that, I get minus 6. And that's it. So 8x to the power minus 5 differentiates to minus 40x to the power minus 6. Okay, minus 5, take away 1 is minus 6. That's what the power becomes. So doing the same thing really, you just have to be careful about it. So something like this, f of x equals 7x to the power minus 5. Take away 4x to the power minus 3. Okay, right, let's do something like that. Right, its derivative function, right, differentiate each part. Right, this one, 7, okay, the power is minus 5, so multiply them, that gives you minus 35, right? And then it's x to the power of, right, take 1 off the power again, you get minus 6. Okay, right, here's where we need to think, because this minus here belongs to the 4. Okay, so it belongs to that 4. So if we take that minus 3 and multiply that minus 4, we get a positive 12. And then x to the power, right, take 1 off the minus 3, it gives you minus 4. So this differentiates to plus 12x to the minus 4. So the derivative function is minus 35 x to the power minus 6 plus 12x to the minus 4. So just be careful with the negative there. Alright, now let's look at some funnier ones like this. F of x equals 7 over x to the power 6. Right, this is where knowing your laws of indices is really, really crucial. If you are not confident with your laws of indices, you need to go back and revise this, okay? Because I'm just going to rewrite this. And I'm going to rewrite it using negative powers, okay? You need to think about how you can rewrite something like 1 over x to the power 6. Because this function is just 7x to the power minus 6. If you remember, 1 over x to the power 6 can be written as x to the power minus 6. Okay? Negative powers represent reciprocals or fractions like this. So when you have something along the lines of 7 over x to the power 6, you can rewrite that as 7 times x to the power minus 6. And then its derivative function is just, well, okay, the power multiplies the number in front, so you get a minus 42, and then take 1 off the power, you get a minus 7. Okay, so it's minus 42 x to the power minus 7. And you should really rewrite that, really. You should rewrite that as minus 42 over x to the power 7. Okay, so that negative power puts the x onto the bottom. Let's do one more like that. F of x equals, let me think, let's say 5 over 3x to the power 8. Okay, right, now think about how you can rewrite this, because the x to the power 8 is on the bottom. Okay, the 3 can stay there because I'm just concerned about this x to the power 8. Well, I can rewrite this function as 5, and I can bring the x to the top as long as I stick a negative power to it. So it's x to the power minus 8 over 3. Okay, and then if you want to differentiate, so I've rewritten the function by putting the x to the top, and you got a minus 8 there. Okay, so its derivative function, okay, whoops, why did I write that? Its derivative function, f dash of x, okay, the minus 8 is going to multiply the 5 really, so that's going to give you a minus 15. Oh, sorry, what am I doing? Not minus 15. And minus 8 times that 5 gives you a minus 40. X to the power, well, take 1 off the power, you get a minus 9 over 3. Okay? And therefore, you can rewrite that as minus 40 over 3x to the power 9 to put the x back on the bottom because it's got a negative power on it. Right, so that's how you deal with these fractional bits. Okay, you can just rewrite it as a negative power and then just follow the same steps. Right, let's look at some funnier ones like this. Something along the lines of this: f of x equals 6x cubed minus 5 over x plus 7. Okay, what happens here? Right, well, first of all, okay, you know what? I'm just going to rewrite this bit here. I don't like this. Okay, so I'm going to rewrite that as minus 5x to the power, well, think about what power's on the x at the moment. It's a 1, right? So you stick a minus 1 there, plus 7. Okay, and that's the function rewritten without the fractional bit, right? Okay, and then what do we want to do? We want to differentiate it, but we differentiate each component. Okay, so this has got no negative power, but the 3 times the 8, so you get an 18x. And then what happens to the 3? You take 1 off it, so you get a 2. So that differentiates to 18x squared. Take away, oh hang on, is it going to be a takeaway? Right, well, the minus 1 multiplies the minus 5, so you get a plus 5. X to the power minus, well, take 1 off the power, minus 2. What happens to the numbers on their own? They just disappear. You get a plus 0 on the end, so that's just nothing there. So that differentiates into nothing, emptiness. Right, and there's your derivative function. 18x squared plus 5x to the power of minus 2. You should really rewrite that as 18x squared plus 5 over x squared. That's the derivative function for this function. Okay, there you go. Right, a couple more. Okay, let's look at. Oops, let me clear the screen. Actually, let me go back to the top. Let's look at doing something like this. Okay, what do you do in this sort of scenario? F of x equals 7x to the power 5, take away 6x plus 8, all divided by x cubed. Okay? Right, we need to be confident with how we can rewrite a statement like this. Okay, because all we have on the bottom is just an x cubed. Okay? We haven't got anything more complicated than that. We haven't got like an x cubed plus 8, and that would make things worse, but we just got an x cubed. Right, and you need to think about the distribution law, because if I take this function can be rewritten as this. If all of this is being divided by x to the power 3, then I can rewrite it as each bit being divided by x to the power 3. Okay, so it becomes 7x to the power 5 divided by x to the power 3, and 6x over x cubed plus 8x over x cubed. Okay, so all I've written is just each component divided by x to the power 3. Okay, it's the distribution law. It's like this. Okay, if you wanted to work out 10 plus 5 plus, I don't know, 20 divided by 5, right? You can just divide each bit by 5, can't you? You know, and you'll get the same answer, right? So that's all I've done is I've just rewritten each bit over x to the power 3. But that helps us because now we can just use some of the laws of indices to simplify this, right? Because this, well, okay, what happens to x to the power 5 divided by x to the power 3? You just subtract the powers, right? So you get a 7x to the power of 2 on the top. Minus, right? Okay, minus, and then what happens here? You got a power 1 over 3, so that becomes 6x to the power minus 2. It's convenient doing it this way rather than just writing it over, 6 over x squared. Okay, and then what happens to this one? Well, you've got an x cubed on the bottom, so rewrite that as x to the power minus 3. Okay, right, so this function has just been rewritten to this, and then using some laws of indices, subtract the powers. 5 take away 3 is 2, 1 take away 3 is minus 2, and then that's just x to the power minus 3. This has been rewritten as 7x squared, take away 6x to the power minus 2 plus 8 x to the power minus 3. Okay, and then we'll just need to differentiate this very nasty looking thing, right? So let's differentiate it. So differentiate each component. So that 2 multiplies is 7, so I get a 14x to the power of 1. Take 1 off the power, gives you a power 1. Minus, oh no, it won't be a minus, will it? Because that minus 6 is going to get multiplied by minus 2, so I'll have a positive 12. X to the power of, take 1 off the power, gives you a minus 3. What happens here? 8 gets multiplied by minus 3, so that gives you a minus 24. X to the power of minus 4. Take 1 off the power, get us minus 4. And there you go. That's that differentiated. Okay? So that's how you deal with negative powers. Okay? Rewrite them as fractions. And then if you have something like this nasty looking thing, you know, rewrite each bit being divided by x cubed. And then use your laws of indices to simplify it further, like this. Okay? And then go ahead and then differentiate each bit. Okay, and then there you go. There's your final derivative function for this original function. Okay, and that's it. Right, next clip is how to deal with powers and that sort of thing. Alright, I'm going to stop.